oil thickens and is harder to pump. The result is inadequate engine lubrication and higher fuel consumption. Finally, the effectiveness of the oil additive is also compromised by soot particles. The centrifuge helps make the additive effective for a longer period. These fine contaminants in the lube oil are filtered out by the centrifuge fitted to the bypass. On the pump pressure side, part of the oil flow is directed to the centrifuge. The pump pressure forces the oil via a hollow spindle in the rotor. The rotor then fills with oil. In a way similar to the principle of jet propulsion, the rotor is then forced to rotate. Particles are displaced through centrifugal force and deposit on the rotor wall to form a filter cake. After separation, the oil leaves the rotor through tangential nozzles. The centrifuge is opened and cleaned according to the specifications of the engine manufacturer. The oil is directed to the oil sump. The centrifuge has a direct influence on the economical operation of the engine. It significantly reduces engine wear, leads to a longer engine life, and reduces the costs for lubrication oil. The long journey of diesel fuel from the refinery to the filling station and vehicle tank up to use in the fuel injection system exposes the fuel to a number of contamination sources. Contaminants can be particles, but may also be just water. Modern injection systems generate pressure substantially over 1000 bar. This enables adequate fuel atomization to ensure efficient combustion. These injection systems are sensitive to fuel contaminants from particles or water. Free water sometimes appears if there are temperature fluctuations. This leads to corrosion in various parts of the injection system, with considerably more wear and consequential damage through rust particles carried with the water. MANN+HUMMEL fuel filters for water separation with filter media such as the patented multigrade media offer effective protection for the injection system against ingress of water. As an option, the preliminary filter is also available with electrical heating for improved flow characteristics at low temperatures. A water sensor is also available for automatic water detection. The preliminary filter is usually fitted to the suction side of the engine fuel pump. The free water drops there are relatively big and therefore better to separate than after going through the feed pump, where they are agitated and become smaller. The preliminary filter is naturally also able to separate coarse particles. This means that all system components downstream are protected and the service life of the main filter is extended. So how does water separation work? MANN+HUMMEL uses hydrophobic filter media to separate water. Small water droplets collect on the media surface and these grow to become larger drops. Gravity acts on these large drops. Water is heavier than diesel, and so the large drops sink down to the water collector in the preliminary filter. Servicing is easy. At regular intervals, the water screw is opened and the separated water is removed from the water collector. The spin-on filter is replaced according to the specifications of the engine manufacturer. The system is ventilated by opening the air vent screw and operating the manual pump. The filter is ready for operation almost immediately. In particular, sensitive components such as the high pressure pump and the injection nozzles have a very fine clearance. At high pressures, the fuel has to be cleaner because any particles in the fuel fly around in an abrasive and destructive manner. The result is internal leaks, injection volume loss, and even total failure of the injection system. The main filter ensures that these small destructive particles are not given the chance to damage the injection system. The main filter is usually fitted to the pressure side of the engine fuel pump. The available pressure drop is higher there than on the suction side, and this has a positive effect on the service life of the main fuel filter as particle separator. MANN+HUMMEL has an extensive range of different media for the various types of injection systems. As is usual with spin-on filters, servicing is limited to the replacement of the filter according to the specifications of the engine manufacturer. It is often difficult to see the risk of using cheap filters. They look okay on the outside, but the inside of the housing is already rusting and therefore weak. Damage caused by cracked and leaking filters is just a question of time. Frequently, cheap filters do not have the required separation efficiency, and so particles are able to pass through to the clean side and damage the injection system. Their service life is also very limited. Their low particle holding capacity quickly leads to higher differential pressure, and the engine receives insufficient fuel, which leads to a loss of performance. In the worst case, the medium will tear, and the highly sensitive injection system receives completely unfiltered fuel. Crankcase ventilation is an inconspicuous but technically innovative separation method to lower engine emissions. We have to look at the inside of the engine to understand how crankcase ventilation works. During the combustion cycle, leakage between the piston rings and liners causes combustion gases to enter the crankcase. These gases, which come from the combustion process, have a composition similar to exhaust gas. They are called blow-by gases. In the crankcase, the blow-by gas is enriched with oil. This gas is not eco-friendly, but still has to be continually removed from the crankcase to prevent an inadmissible rise in pressure. In the simplest case, this removal is made via an opening in the crankcase. However, this method results in a continual loss of engine oil and is no longer environmentally acceptable as a solution. A better solution is to remove the blow-by gas via an extraction point on the engine, such as via the rocker cover, and ventilate the crankcase using a highly efficient oil separator. The separator can be operated as an open system where the cleaned blow-by gases are returned to the ambient air. A state-of-the-art feature is the closed crankcase ventilation system, where blow-by gases are recirculated to the engine air intake to return to the combustion process. The oil separator exploits the principle of coalescence to separate the oil. As blow-by gases pass through the medium, small oil droplets collect on the fibers of the separation medium, grow and then exit the filter in drops on the outlet side, where they return to the oil sump. The cleaned blow-by gases are then returned to the engine air intake and sucked in again by the engine. With closed crankcase ventilation, there is a hydraulic connection between the engine air intake and the crankcase. Therefore, the constantly changing pressure difference between the air intake and crankcase must be compensated for by pressure regulation to ensure the pressure level is suitable for the crankcase. Due to the adjustment of the pressure in the oil sump, the oil recirculation usually takes place below the oil sump. The oil column in the drainage pipe then prevents a bypass via the drainage pipe to the air intake. If this is not possible or not desired, the oil recirculation can optionally be made above the oil level. In this case, MANN+HUMMEL offers a valve for fitting in the drainage pipe, which will prevent this bypass. As a further option, MANN+HUMMEL offers a pressure relief valve for a number of crankcase ventilation systems, which prevents inadmissibly high crankcase pressure in the event that the engine fails. The servicing of the oil separator could not be easier. The crankcase is opened without tools. Then the separation element is replaced according to the specifications of the engine manufacturer. Modern diesel engines are frequently supercharged to realise high performance with ever smaller engines. The result is that soot particles in the exhaust gas are becoming ever smaller and barely detectable to the human eye. The separation of very small particles is a challenge for the filter medium. Improved back pressure exhaust gas characteristics, long service life, and high filter efficiency for ultra-small particles are good arguments in favour of the sintered metal filters from MANN+HUMMEL. The filtered soot particles deposit themselves on the filter surface, and the soot particles form a filter cake. The active electronics monitor this process and automatically trigger regeneration. The vehicle driver is not aware of the regeneration process. An electric heater ignites the filter cake without direct contact, and the regeneration is carried out automatically. The cleaned filter is now as good as new, apart from a small amount of ashes which, due to the open design of the sintered metal filter, falls to the bottom of the filter. Depending on the application, the ashes must be removed from the filter after a time period of up to 2,500 hours. High filter efficiency, long service life, easy servicing, and unlimited availability of the application. All these arguments make MANN+HUMMEL diesel particulate filters the ideal solution for your engine and the environment.